Welcome to this special episode of Frequency Matters, the R for Microwave Update series. I'm Pat Hindle, and I'm talking with Robert Danderaw, Product Marketing Manager at Analog Devices. Welcome, Robert.
Hi, Pat. Thanks for having me.
So ADI made a huge announcement at IMS this year, introducing the new wideband mixed signal front-end platform called Apollo MxFE. So can you tell us a little bit about the new products here and what are some of the key specifications?
Sure. So Apollo MxFE consists of two different variants today, and we're developing a host of wideband transceivers under this trade name, Apollo MxFE. So the first two parts is the AD9084. This is our widest band transceiver. So this is a 4T, 4R device that can sample at 20 gigasamples per second on the ADC and 28 gigasamples per second on our DAC. The RF bandwidth is from DC to 18 gigahertz, and the instantaneous bandwidth on that device is up to 10 gigahertz. The second variant is the AD9088. So this is an 8T8R in the same package as the 4T4R. And this device can sample at 10 gigasamples per second on the ADC and up to 16 gigasamples per second on the DAC. The RF bandwidth is significantly close to the 4T4R. It's actually up to 16 gigahertz. So it's exciting that we can now direct sample to X-band with the 8T8R variant as well. And the instantaneous bandwidth is about 4 gigahertz on the 8T8R part.
Wow, those are some impressive specifications. So what markets and applications do you think will be best suited for these products, and what differentiates them other than these impressive specs?
So three big buckets for us is, of course, aerospace and defense, specifically, phased array radar and electronic warfare. The second is instrumentation, and the third is wireless communications. So what differentiates us in the phased array radar space, the 4T4R part was really designed to direct sample X-band with really high dynamic range and noise spectral density. And then the 8T8R part was designed for more ground and naval ship radar, where you're targeting L, S, and C band at really good performance. So when Apollo was developed, the idea was to give our customers narrow band performance at really wide bandwidths. So I think this is something that is unique about Apollo and really differentiates us. On the instrumentation side, we're targeting ET&M, or electronic test and measurement. So things like spectrum analyzers, oscilloscopes, and then also automated test and measurement. So folks that are doing like comms testing are very interested in Apollo because of its wide bandwidth and really good performance. And then, of course, we're looking at wireless 6G infrastructure. Things like millimeter wave are interested because the bandwidths keep going wider and wider. So Apollo is of interest in that space as well.
So these are really highly integrated chips. What functions are included and how flexible are they in their configurations?
Yeah, great question. So over the years, maybe over the last decade, ADI, we were integrating really more towards the antenna, and that is to say, increasing our sample rates. So you no longer needed a mixer in the front end. You can now direct sample, even up into KU band with the 4T4R variant. And so with that, more recently, we've been integrating more towards the FPGA by adding more and more digital onto our chip. So Apollo is the largest digital chip we have done to date. It's more than 50% digital. So what that does is allows us to offload some of that FPGA compute to Apollo, which is essentially a digital ASIC. So apples to apples, you can save quite a bit of power consumption if you move some of that digital processing from the fabric of the FPGA to Apollo. So some of the blocks that we have is we have on-chip decimation interpolation filters with independent NCOs, and these are fast hopping NCOs for defense type applications. We have a new block on Apollo called an FFT sniffer. This was designed primarily for electronic warfare, where maintaining situational awareness and broad spectrum and congested spectrum is really important. So Apollo allows them to quickly look at the full 10 gig of Nyquist and use the FFT sniffer to to sort and identify potential threats, and they can hop using those NCOs to those frequencies to do surveillance, to do some jamming, or they can look for a clean spectrum for communications, for example. There's also things like programmable filters on Apollo. So there's a 32-tap programmable FIR filter that's available at the full 20 gig or 28 gig sample rate. And there's also a complex FIR filter on the back end of our DSP. And so you can do your equalization, you can do things like quadrature error correction. Again, things you're commonly doing in the fabric of the FPGA that you could consider moving to Apollo's DSP and save quite a bit of power. There's also a fractional sample rate converter on Apollo that allows you to do a final decimate or interpolate any number between 1 and 2. And so why this matters is traditionally you're kind of limited, your final data rate to the processor is connected to your clock rate because your decimation filters are half band filters typically, sometimes a third band filter. But if you want a very specific data rate to your processor, this fractional sample rate converter allows you to do that. And all of the DSP on Apollo is dynamically reconfigurable. And this is probably one of the most interesting, strongest value propositions of Apollo is now we've achieved the ability to have a narrow band and wideband profile device in one device. And you can quickly hop between a narrow band profile and a wideband profile without taking the JESD link down, without having to recalibrate the chip.
Wow, that's a ton of functionality on that chip. So what types of simulation models and evaluation boards are available then?
Yes, so we have a comprehensive MATLAB model for the Apollo MxFE. So if customers are interested, they could reach out to us and we can get them that model, and that allow them to start modeling the DSP and seeing how that functionality can work for them. And then in terms of evaluation boards, we are currently bringing up our final silicon in the lab. There's a lot of work to get through all of the features and the characterization of the part. It's so highly programmable. So evaluation boards we're targeting towards the end of this year with a full product release in April, May of 2024.
And so I think this is the second major evolution of these software-defined radio platforms. How do you see them evolving further in the future?
Yeah, it's a great question. So this Apollo generation is on TSMC 16 nanometer. We anticipate we'll be able to bring to market higher sample rates, even more digital, all at lower power. So I would say power is probably one of the areas we're really taking a look at. And then we're talking to our customers in EW, radar, instrumentation, and comms, and kind of asking them where do they need us to be, and looking at those different trade-offs. There's 2 or 3 or 4 very interesting products we're exploring.
Well, thank you very much, Robert, for talking with me today about the new analog devices, wideband mixed signal front end, the Apollo MxFE and its capabilities. I definitely think this product is bound to be very popular in the market, and it's going to be utilized in many different applications. So we're excited to see what happens. To our audience, you can find more videos at videos.microwavejournal.com. Thanks for listening.